So first component of the system, the donal gauge. The donal gauge connects to the motor after the Y points. So here you have two pictures of donal gauge. If you want to see what a Y point looks like, this is one Y point over there. I think I've probably showed that in my ESP motor course. So basically at the bottom of the motor, the three phase of the motor will connect to each of these three pins over there. And so they will connect together somewhere inside of this piece. And then you will still have this red cable that will be used to connect it to your ESP gauge so that the DC signal can be sent to your ESP gauge. The donal gauge gathers all the sensor to a single point. So inside of your gauge over there, you're gonna have one sensor for each of the parameters which are being monitored by your gauge. And so each of these sensors will be powered through this single cable over there. In terms of material, the gauge typically comes with a housing of carbon steel or stainless steel, and it is usually compatible with any motor brands and size using motor head adapter. So this is what we can see on this schematic over there. We can see that you have different motor head adapter over there that you can then connect to the bottom of your motor, and they will basically act as a crossover so that you can use an ESP gauge that can be of a different brand than your motor. So to take an example, it is possible to use an ESP gauge from Leva or Novomet at the bottom of a Schlumberger motor. You just need to have a crossover for that. Now, as explained in the system architecture video, the current which is being pulled by the ESP gauge, these currents will change depending on which sensor value is being read by the surface panel. So basically what the gauge is doing is that it modulates the current based on the parameter measurements. And so how does that work? Basically, the gauge communicates sequentially the measurements to the surface. So your gauge basically is connecting this power sent from the surface to the first sensor, for instance, the pump intake pressure, allows this sensor to communicate with your surface panel. Then it changes the connection and connects the power to the next sensor, for instance, the pump discharge pressure, allows it to communicate with the surface panel, and then moves on to the next sensor. So it allows this sequential communication. Now, what is the consequence of that? The consequence is that you're going to have one reading every several seconds. So in the case of Schlumberger gauges, for instance, it is every 20 seconds, but this can vary from one supplier to the other. So for instance, with Leva, it's about every 15 seconds that you will have one new reading of a sensor. I took a look at Alcorayev. They've got the Spectrum Advanced Ground Fault Tolerance ESP monitoring system. So with their gauges, they are able to communicate new values every 2.5 seconds. So that's a lot less. So as you can see, this duration can vary from one supplier to the other, from one gauge to the other. How does it look like? If we draw a curve, you will see something like that, where on the y-axis, you've got the current which is being sent to the gauge by the surface panel measured in milliamperes. And basically, the gauge will initially send the C0, so that's the current zero. This is basically the power pulled by the gauge when no sensor is being powered. Then it will pull the CFS, so this is the current full scale. So that's the maximum current which is being pulled by your gauge. And then the gauge will connect your power cable to the first sensor. So in this example, it's the discharge pressure. And so the discharge pressure sensor is going to be powered by the gauge. And so the gauge allows the pressure discharge sensor to communicate with the surface panel and send the value back to the surface panel. Then it will move to the next sensor. So it will then connect the intake pressure sensor to the cable, then the intake temperature, then the motor temperature, then the vibrations, and the sequence will finish by a leakage current measurement. And so once you are done with this full sequence, so with Schlumberger it takes about 20 seconds, then you start a new sequence where you're gonna restart basically this sequence from the beginning and again sequentially sends one measurement for each of these sensors. So for operators, the pump intake pressure tends to be a very important parameter because this is the one that drives well performance. So they are usually keen on getting more frequent values for this parameter than for the other. For that reason, with Schlumberger gauges, you have a mode which is called the rapid rate sample, RSR, where the gauge, instead of sending sequentially each parameter one after the other, it is only sending updated value of the pump intake pressure, and in this case, it is able to send one updated value every second. Baker Hughes, on their hands, they've got a system which is a bit different, and to respond to that request of operator to have a higher frequency of data reading for the pump intake pressure, what they do is that they send one parameter reading, so for instance the pump discharge pressure, then they send the pump intake pressure. Then next they will send the next parameter, so for instance the intake temperature, and then after that they will send again the intake pressure. Then they will go to the next parameter, the motor temperature, and then again the intake pressure. So every other parameter they send back a value of the pump intake pressure. The next thing that I wanted to discuss on this slide is the communication. So most gauges uses analog communication to the surface. So you actually have two main ways to communicate with your gauge. You can either have a digital mode or an analog mode. So I have a dedicated video to explain a bit more the difference between the two later in this training. At this point, what I would like to mention is that the Phoenix gauges from Schlumberger and the Zenith gauges from Baker Hughes, they now all use analog communication with the gauge. Now for Schlumberger in the past, I don't know if that's still the case, but they had some downhole gauges which were not ESP gauges that were using digital communication, and I know that some ESP manufacturers only use digital communication for their gauges. For instance, that's the case of Oil Dynamics and Leva. They communicate with their gauge using digital mode. So just to briefly talk about it, again, I have a dedicated video about digital gauges and the difference with analog gauges later on. But basically for the digital gauges, the communication with the gauge is coded at the gauge level and it's sent back to the surface by data pack. And so the surface panel needs to receive several of these data pack to then have a full reading. So because it is a different communication mode than the analog gauge, the frequency of data updates is going to be different than with analog gauges. Now, a last slide on downhole gauge to discuss the discharge pressure and entry guides, also called fin guides. So let's start by that. And basically, what I wanted to mention is that the downhole gauge is used to connect to the entry guides, also called the fin guides. So you have pictures of some of them over there. So on this picture there, we have in blue there the downhole gauge, and down there we've got this entry guide. So it is actually this piece. It is being used to center the ESP system when you run it in hole to avoid damaging it by scratching it to the side of the well. So here on this picture, it's quite nice to see that you can have quite different size of entry guides. So there we have a much larger one than this one. So basically this piece, you will choose a different size depending on the series of your ESP system and depending on the casing size. So second point, the downhole gauge connects to a discharge pressure sub through a 1/4 of an inch tubing. So basically, when a gauge is equipped with a discharge pressure transducer, so when it has a discharge pressure sensor, you need to have a discharge pressure sub in your assembly. So you have a picture of one over there. This discharge pressure sub is mounted at the top of your ESP pump, so just above your ESP pump. And you will have a 1/4 of an inch tubing that will connect this discharge pressure sub to the downhole gauge. So over there, we've got the downhole gauge, and we can see this 1/4 of an inch tubing. So it will basically connect back to this discharge pressure sub. So you actually have a schematic over there which shows that, where you have again the discharge pressure sub over there, this 1/4 of an inch tubing, and the discharge pressure port in your gauge. And so basically the pressure that you have inside the tubing there, you have a little hole on your discharge pressure sub so that it communicates with this 1/4 of an inch tubing. Then this 1/4 of an inch tubing, inside of it, you have the same pressure than what you have at the discharge of your pump. And so it sends back this pressure to this discharge pressure ports at the gauge level, and so it will allow the gauge to read this pressure. I had actually represented that on this schematic seen previously on this training, where in orange over there, this is this 1/4 inch tubing which connects the discharge pressure sub installed just above the pump to the ESP gauge installed below the motor. And so that's all I wanted to tell about the donal gauge. So now let's move to the next component.